One thing we can do to find the line of best fit is to find the line that minimizes the sum of all the residuals. The only problem is that the residuals are either negative or positive. And so if we had something like this, say, these negative and positive residuals would just balance each other out. We could have a line of best fit that doesn't go through the points at all, but still has a very small sum of the residuals. We're kind of in the same situation where we were figuring out how to measure spread. We looked at possibly the average absolute deviation then from the mean. Similarly, we could look at the absolute residual. In other words, even if the residual is negative, just look at the positive value. This is one method, but the standard method is to minimize the sum of squared residuals. In other words, we'll square all the residuals to get rid of the negative sign, add up all these squares, and then minimize this value. In symbols, this would be the observed y value minus the expected y value, which you remember was y hat, and this is the y value that corresponds to that x value on this regression line, squared. When we have a function, we can use calculus to find the maximum value and the minimum value. When we say value, we mean the x value. Where does the max or min occur? In other words, at what x value? We can also use calculus to minimize this sum of squared residuals and find out what our regression coefficients should be. When we use calculus, we get that our slope is equal to this. This is a long, tedious equation, and you won't have to use it. It just so happens that this is equal to r, remember Pearson's correlation coefficient, times the ratio of the standard deviation of the y values to the standard deviation of the x values. Isn't that awesome? Let's use it to find the slope of our regression line for the airplane example.